Hey guys, in this section, we're going to get down to some fun stuff. So we've been looking at a lot of theory, a lot of concepts, and just getting to understand the inner workings of Azure Functions. In this section, however, we're going to put all of what we've learned to the test, and we'll be building out a REST API. So we'll just be using functions, building out endpoints. If you are not familiar with REST APIs, you can check out my other courses on REST API development, where we actually go through how to build them using a whole API development project template from Visual Studio. But here we're going to be using Azure Functions. So in this video, let's just get started. We're going to be using Visual Studio for this one. Let's just find the Azure Functions. Once again, if you don't have it to the left, you can always search. And if you don't have it at all, you'll have to go and get the installer and install the Azure workload. So let's get Azure Functions, and this one I'm going to call it shopping cart list. So I think that's a simple enough example. We have items that go in the shopping cart and we tick them off when we have them, right? So we can just go ahead and create that. And for now, I'm going to do an empty template. So for the storage emulator, yes, we want to use a storage emulator. We already went how that works. And just for context, at this point, the traditional Azure storage emulator may not necessarily work properly. And I would have mentioned that you would have to use Azure, right? So to make sure after you have installed it that it's running, you can always just run that command Azure, right? And then you'll see it starting up all of the services, right? So if you encounter any difficulty connecting to, or you're trying to use these emulated services and it's telling you can't connect, just run that command Azure, right? All right. And I'll just have that running in the background. So for now, let me go ahead and create this empty template. And when we come back, we're going to get started with creating our functions and looking at the concept of how we're going to lay it out in terms of building out a REST API-like structure. All right, so let's get this started. I'm going to add a function, so new Azure function. And since we're dealing with an API-like structure, then all of my functions need to be HTTP triggered, right? So I'm going to call this shopping cart function or shopping cart API. Let's call it that, and add. And then I'm going to go with the HTTP trigger. I'm going to make it anonymous, at least for now, and click add. All right, so now we have our function. I'm not going to start modifying it just yet. Instead, I'm going to go ahead and put in some other things. So I'm going to add a new folder. I'm going to call it models. So the thing with API development is that you typically want to have models or DTOs that govern what data you expose / interact with for each request. So I'm going to have a shopping cart model, first of all. And I'm going to make this, well, it's internal. So internal means that it can be used by anything inside of the same project. So I can leave it as internal for now. And I'm going to add some properties. So I just went ahead and did all three classes, and you can just look at them and replicate them accordingly. So we have the shopping cart item, or shopping cart in general, or actually this should be a shopping cart item, right? So let me just update the name of the file accordingly. Let me just do that. Cool. So shopping cart item has an ID, which I'm just going to use as a string GUID. I have a date created, and then I have the item name, and then I have, is it collected or not? You know, like on a shopping list, you strike off the item once you've put it in the cart. So that's pretty much what that is signifying, right? And then we have one for the create. So of course, for the create, I'm not going to expose everything. I don't want the user to be in charge of the ID or the created, and Booleans default to false. So without me specifying that or needing that from the user, I'm assuming that it's not yet collected. So all we need is the name of the item. For the update, you may be changing the name of the item. You might also just be changing collected, or I could just allow them to just say, yes, it's collected or not. So I think I'm going to keep it that simple and just work with that. Later on, when we're connecting to the database, then we'll have to create some more models. But for now, this is all that we need. So in a REST API, these would be what you call DTOs, or data transfer objects. Once again, if those terms you're not familiar with them, you can always check out my course on API development. However, let's jump back over to our function. And then what we're going to do here is actually establish our roots. So the thing with functions is that by default, we're getting this class, yes, and then we're getting one function with run, right? In this case, it's saying it can do get, it can do post. We don't really need anything to do both, because in a REST API setting, it should be very strict. One for posting, one for get, or at least at the very basic level. But each function should be in charge of one operation at a time. So since we're mimicking that REST API structure and standard, we're going to have to modify this. So what I can do is rename the function. So if this is supposed to get shopping cart items, I can call this get shopping cart items, right? So that's the function name. However, for the root, I want to specify a value, because I don't want that when you call the function, you have to say /API/ this function name and then that function name. Once again, REST API standards would have you call basically one API, one structure, but based on your verb and potential parameters or values being passed over, then it would know which function exactly you are referring to. So we're going to rename this root so that it looks a little bit more like what a REST API would look like. So I'm going to call it shopping cart item. So you're expected, because it's already going to be the URL /API/ and then the function name. But when I specify this as a root, then it will know that from the HTTP request, anything going to that root after the /API will be going to this function, right? Next thing is that I don't want this function to post. I want it to retrieve. So I'm going to remove that post, and just to make sure everything looks good, I'm also going to rename the function itself to reflect what that function name is, so that everything looks kind of uniform, right? For now, I'm going to remove all of this. Yeah, I can just remove all of this from the function, because what we're going to be doing doesn't require all of that per se, right? So that is the one to get. Now, once again, we're doing a REST API, so that means I need one to create. So I'm just going to copy all of that, and I'm going to call this one create shopping cart items. I'm going to give the method that name, and this one is going to be the post, because it's not getting this time, it's creating, and anytime you create, you should use post, and then it has the same root. So it's going to be a post request to that API or that HTTP root. This one is a get request to that HTTP root, right? And then we can do the same thing for put and delete. So put would be for updating, and deleting, well, I think that's self-explanatory, right? So put shopping cart items or item, and let me just make sure that my methods are really reflective of what the operation is going to be. So delete shopping cart item, delete shopping cart item. This one is a put request, and this one is a delete request. All right. So once again, we're just mapping out routes. They may change as we go along, and we might see something that we want to change. Of course, we're going to be changing the parameters when we're focusing on each one, but for I'm just mapping them out so we get the big picture. There is another type of get, because maybe we want a specific one. So if we wanted a specific shopping cart item, then it would be get shopping cart item, not items. This would also be a get, but then for the root would be shopping cart item / and then we're going to use a binding parameter to let it know that it should expect something called ID afterwards. So we have get all the items, right? We have get by ID, pretty much. Get shopping cart item. If you want to qualify it, just so you're very clear and you know that that is what it's for. But all it is just that / the ID. We have the create, which is just a post. and then we have the put, and we have delete. Now that we have a good idea of the big picture, when we come back, we can start working on them one by one. All right, so we're back and we're going to start off with the create shopping cart item. So first, let's update our log message, and it's just going to say creating shopping cart item, right? Now, in the request, we do have the data coming. We've already seen that this request could have looked in the body or in the URL, and since it's a post, we're expecting the data to come in the body. So I'm going to start off with a variable called string request data, where we're going to await a new instance of the stream reader. And the stream reader is going to go into our HTTP request parameter, rec.body. And then we want to read, or read to end rather, async. All right. Now that we have read it, this is going to return that JSON body pretty much. We want to serialize it into our create shopping cart item object, right? So I'm going to say var item is equal to, and I'll use JSON convert. Now JSON convert comes from our Newtonsoft library, and that was already included. Here, it's basically a requirement for HTTP triggered functions. We've seen it, we've used it before. But my point is that it's like any other package, it's just a NuGet package. So if you already know how to get packages in, you can just go to manage NuGet package and add it right here without any qualms, right? So we want JSON convert.deserialize object, and we want to deserialize into our create shopping cart item object. And then we give it the request data, which we know is JSON in nature. Then after we've done all of that, we would want to add it to some database, right? Pretty much our database is going to be of type shopping cart item because we want the defaults, right? So before I do all of that, let me just create a new instance var. Okay, let me change this from item to data, right? And then I want to say var item here is equal to a new instance of the shopping cart item. And this new shopping cart item is just going to take that item name, which is coming in from data.item name, right? So once we have that object that we would want to save, we want to save it to a database. So I am not yet ready to start up the whole connect to database stuff. So what I'm going to do is just create a static list. So I'm calling it shopping cart items is equal to a new instance. So down here, I'll just say shopping cart items dot add our new item. Now let us pause for a minute and reflect on the relevance of using this list, what the pros and cons are. Obviously, in a real setting, we wouldn't be using a list like this. We'd be using a database. However, I'm not ready for the database just yet, so we're going to be using the list. Now, the thing with a function app is that while it is running, it is going to be storing any data, any variables during the runtime. So while we're testing, this is perfect because we can call all the different methods and we'll be interacting with the same list. In a production setting, remember that functions are able to scale. So that means that if you were to deploy this, while it may work for some scenarios while your function app is running, because remember that on some plans, it will actually be turned off until you have to spool it up again. So that's one danger. But two, let us assume that doesn't happen. It can scale to have multiple instances. So then you would end up with multiple instances of the list, which is another danger. So of course, that's why we would want one database. But for now, we'll just use our list. So after we add it to the list, we can then return a new OK object result. And I'm just going to pass in the new item, not the whole list, but just the item that was now created. So that's really it. All of our errors for our create shopping cart item are gone. And that is step one. So when we come back, we'll be going into our gets. So we'll just do both gets in one go, right? Get all versus get by ID. All right, guys, so we're back, and in this lesson, we're going to be focusing on our get methods. So the first get method, which is to get all items, that one is fairly straightforward. So my message is going to say getting all shopping cart items. And then all we're really going to have to do is return. So at this point, we would really go and query the database and say, give me all, right? In this case, we don't really have a database. We only have this list. So all I'm going to do is return an OK object result with the list. So that's the list of the shopping cart items. And once you want all, you get all. So that's pretty much it. I have an error here. Sorry, I missed off my new. Return new OK object result. There we go. So that's really it. Now for the get by ID, it takes a bit more finesse, right? So yes, we have the same root. We know that this one is expecting an ID value coming in. So that ID value usually comes in as a parameter. So in an HTTP request, it could have come in as the HTTP parameter. I'm going to add a new parameter here as a value. So string ID, and then I'll just use the comma. So string ID is going to represent the ID value that should be passed in when this function call is made. I'm actually going to put this as the last thing. So I'm going to put it after the iLogger. String ID. All right. So once this method is called, we're expecting this ID. Now, once we have that ID, and I'm just going to rewrite the logger message, getting shopping cart item with ID, and then I'm just going to encapsulate the ID value that's being passed in, right? Sorry, interpolate, not encapsulate. So now that I have that, I'm going to say var shopping cart item is equal to, I'm going to go to my shopping cart items list, and then I'm going to say dot, we could use find, but I'm going to stick to what I am more comfortable with, first or default, because when we do first or default, if it doesn't find it, it will return with a null, right? So first or default, and then control dots to use system.link, and then we put in our lambda expression. So q.id of the shopping cart item will be equal to the ID value that is passed in. And then once we have done that, I'm going to now check, and you see Visual Studio is helping me along. If the shopping cart item is null, meaning, well, obviously it didn't return anything, then we would have to return a new not found object result. So that's a 404, right? Otherwise, okay, so here's the difference between, because you might notice that you have object result versus result, right? So you have OK result different from OK object result. The difference is that when you return the object result, you need to put in data. When you're not returning data, so in this case, I have no data to return, right? It's expecting some value. So I have to say not found result. So they really amount to the same thing. It's really the same 404, but just which one to use when appropriate, right? So we are going to return a not found result. Otherwise, we're going to return a new OK object result with that particular shopping cart item in hand, so that the caller would have gotten the data. So let's review quickly. To get multiple items, get shopping cart items, all I'm doing is running a query, quote unquote, running a query against the data store and returning all. Right now, the data store is a list, so I'm just returning what is in that list. When we want by ID, I have to specify that I want the parameter ID to be present. They're already both get. We already know the roots, but this one is /ID, hence my need for the ID. And then once I have that ID, I try and run the query to find that one object in the data store. If I don't find it, I return not found result. Otherwise, I return the OK object result. So that's really it for the get methods of our REST API. All right, guys, so let us jump over to our put. So we're looking at updating our shopping cart item. Now, we have to make some more changes because when we want to update, we would have to pass in an ID as well as the data to be updated, right? So we're going to have to do what we did up here, which is include our ID parameter. There we go. And we have to update our root because we also need that /ID on the end of the update root. All right. Then we can change out our log message to say updating shopping cart item with ID, pass that in. Now we have to do kind of a hybrid operation. The first thing that we have to find the data. So we can repeat what we did in the get. So I'll just go ahead and say, get me the shopping cart item that has the ID that was passed in as a parameter. If we didn't find it, then return not found. All right. Next, we are going to have to repeat something like what we did with the create. So I'm going to have to parse through the incoming data. And this would be parsing into the update shopping cart item. And then in a bigger operation, we could use something like automapper to map between the incoming data and the shopping cart item to do the updates. But this is a very simple operation. So what I'm going to do is simply update the shopping cart item dot collected flag and let it be equal to the data dot collected flag. So you're updating it. It must mean that you're changing the Boolean from true to false or vice versa. That's all we're really going to be updating. Then at the end of all of that, we're just going to return our OK object result, and I would just return the updated shopping cart item as the object, right? So that's really all there is to the update. So let's go through it again because I kind of took code from different pieces. So let me just explain what we're doing. One, we're finding the shopping cart item with the matching ID that was passed in via the parameter. Then we're going to say if nothing was found, we return a 404. Otherwise, it will continue to say, get me the data that came in the request, because with a put, the data would be in the body. It's very similar to how it would be in the body for the post. So get me the data from the body, parse it out into the corresponding model for updating, and then we're going to manually update. So I'm doing it manually in a bigger operation. Like I said, you would probably use Automapper or some other third-party library or write a converter to have that done. For now, two very simple operations or a very simple operation. So we'll just do that. And then we return the updated object as part of the return result. So that's really it for setting up the put. When we come back, we will do our final one, which is the delete. All right, so let's get started with the delete operation. So I think we've been doing this long enough. If you want to hit pause and try and do it yourself, then I would encourage that. Otherwise, we can just walk through it. I already wrote the code. So we had set up the delete shopping cart item method from before. What we didn't do was flesh out the root. So the root, once again, will require an ID value there. And we have the matching parameter string ID. I updated the log message. And once again, we try to find it. If it is not there, then we say not found result. However, if we continue, we say remove it from the shopping cart list and then return an OK result. Note, not OK object result, but OK result, since there is no data to return. And that's really it for the delete method, right? So with that, if we just do Control Shift and B, we can build and make sure that we have no errors anywhere in our code. And we can see that we have a successful build, 0 errors, and we can continue. So now that we have fleshed out all 4 of our operations, when we come back, we'll just go through some testing. We'll use Postman to call the different endpoints and make sure that it is functioning, or that our functions are functioning the way we expect. All right, so it's testing time. We've done all the hard work. Let us put it to the test. So we can just click the start button here in Visual Studio to start it up, or if you're using Visual Studio Code by now, you know how to run that. And then in our console that accompanies the execution, we get a list of all the functions. So we see all of them by name, thanks to the function name attribute that we added. But we also notice that each one has a root. So yes, the root would have been based on the name that was provided by default. However, we overrode that and we put in our own roots, and there you can see how you can call each method according to the root. So if we test with Postman or any other HTTP testing tool, and I say, okay, call the get all method. So notice, to get all shopping cart items, I would just call that URL, so you can actually just highlight it and then copy and paste it into Postman, click execute, and then you'd see here that you would get that status 200 okay, but nothing because we haven't put any data in, of course. You'd also see the log get updated, so getting all shopping cart items, and then it was executed at that point in time. So let's just try and create a new shopping cart item. So I would just change this method to post, and then in the body, I have to make sure that I send over some JSON. So change that to raw, and then change that to JSON. And what did we specify? In order to create, we are only accepting the item name, right? So I'm going to say item name, then colon, and remember to put in a quotation marks, and then colon, and then this would be test from Postman. So when I click send, let's see, then you'd see it replies with the newly created ID, that timestamp, the item name, and if it's collected, that's false. So if I retry my original get, I'll just open a new tab, use the same URL, but we're using a get, and I send, then I'm seeing that I'm getting back that one item from the list, right? If I try my other get, this one requires the ID, so I'm going to say slash, and then pass in that ID value, copy, paste it there, then I should only get back one object. There we go. So I think that this is working well. Let me try the update. So I'm just creating tabs accordingly. So once again, we have this URL, paste it there, or actually I should have just used this URL, because for the update, we do need that ID value. I'm going to do a put, and then inside of the request body raw JSON, I'm going to say that collected is now true, right? So colon and the value true. Let me send, and then you see here it returns the updated object, letting you know that it is now true. So if I go back to the get all, and send again, then I'm getting back the updated. So like I said, if you call these functions within the same session, I'm going to call it a session. So we're executing right now. We're calling one after the other, one after the other. It's updating the same list each time. So that is why you're getting those results. Of course, if we stop and restart, then that list is going to be emptied out. So it's the same way that a function app, once it's running, if you're using that list, then no problem. But then once it scales or it winds down and then has to wind back up afterwards, you just know that you're going to lose that data. So, you have to be careful with that. But later on, once again, we're going to be looking at using persistent storage in the form of Azure tables or any other storage medium that you prefer. So that is really it. So the last one that I'm going to do is a delete. So I'll use this URL, go over here, and this time the method type is a delete. We have the ID and everything. I don't need a subject body. Response 200 okay, no content. If I go back and try to run a query, nothing comes back. If I recreate, then I get a new ID. And then if I try to look in there again, I see everything. So that is literally all there is, quote unquote, all there is to a REST API. The more difficult it becomes based on your business needs. But at the end of the day, this is how easy it is to create a whole REST API using just Azure Functions. Now, a fundamental part of any API's development is how it interacts with client apps. A client app can be a mobile app, it can be a web app, etc. In this case, I made a simple Blazor app where I wrote code to interact with the different endpoints from our Azure Functions API. So while running it, we know that we have all the roots already, and all I did was retrofit the fetch data page from the typical Blazor app template. And what it does is test from Blazor. When I put in an item here and say create, it will actually update. Sometimes what happens is that when you interact with the console here, it will cause it to pause. So if you just press enter, it will continue. So you see here, it actually made the call, create shopping cart item, and then it did the retrieval, and there's our new shopping cart item, right? If I say test from Blazor 1, and let me just make sure that the console knows that it should operate normally. When I click create, it updates, and that's now in the list. If I click the tick for collected, you see here that it will call the put. Here we go. So put. So it updated it, right? And then if I remove, and once again, I keep on interacting with it, so it pauses. But when I click remove, it should remove the item. Let me try that again. There we go. So let me create a few more, and then let me delete them. Right, so each time I click delete, you'll see it updating the interface. So I'm just going to walk you through the code that I wrote for this. It's not really a Blazor course. I'm not teaching you how to build a Blazor app. I have other courses for that. But just within the context, I'm going to show you that from the Blazor standpoint, it doesn't know or care what the underlying infrastructure of this REST API is. It's just going to be doing Blazor stuff relative to a REST API. So I created a brand new project, and it was just a Blazor WebAssembly app. Simple ways to do that. You just go to the solution, right click, add new project. You look for Blazor WebAssembly app. I'm using .NET 6. Go ahead and create it. And then by default, you're going to get some address here, base address with environment host. I changed that out to be the base address of where I know our functions app will be broadcasting from. Right, so we know that that is the port. We would have done some testing with Postman. We know that that is our standard API route. All right, so that is the base address for the HTTP client being used in our Blazor app. Now, another thing that I want to point out is that we had to set up CORS. So CORS is cross origin reference. Okay, I'm sorry. Here's the definition. So cross origin resource sharing. There we go. So that's a protocol or a set of rules that govern how your API interacts with resources that are not on the same server. So while we were running the function app and testing with Postman, it didn't see a problem. However, when I'm broadcasting or sending a request from an external source like this Blazor app, when it's executing on a different port, therefore it's seeing it as a different app altogether, then it would actually reject it. So this is how we enable CORS on an Azure Functions app. So in our local.settings.json file, we go to host and we open up a new object block where we set CORS to be star, meaning accept all requests, don't have any restrictions, right? Of course, when we deploy to Azure, that will be handled on the Azure side, but for local settings, we have to make sure that is in place. So you can go ahead and do that. I also would have replicated the models folder, so I just redid them down here in the Blazor app, and instead I updated the namespace with shopping cart list.blazor.models, as the name of the app is shopping cart list.blazor, right? So you have the models or access to the models there. Now, another thing that I would have done would be to update, of course, the fetch data.razor, or if you want to make a new page, that's up to you. But I just did everything on one page, and I'm just going to walk you through all of the code that was written. So we have the page title, we have the H1 and the P tags. That's all just, semantics. You can or don't have to do that. Then I have the edit form up top where I have that input text, which I am binding to an object called item create, and I'm accepting the item name. So here in the edit form, the model is item create, and on valid submit, we're going to call the method handle create. So then I have this submit button for my edit form. So item create is of type shopping cart item, and I just have an instance of that there. And handle create is going to just say response await the HTTP client. What is HTTP? That is the HTTP client that I'm injecting into my my component, So that would have been already there because of fetch data. It's actually a sample of how you can interact with the HTTP client. So you don't have to put that there. It should be there already. But what I'm doing in the handle create is I'm saying HTTP dot post as JSON async and then post a shopping cart item. And actually, I just noticed that this is wrong. That should be create shopping cart item. Really doesn't matter in the grand scheme of things, but let's just work with it. So that should be create shopping cart item. So I am posting a JSON body or JSON serialization of create shopping cart item, and it's going to the address API slash shopping cart item. So this API slash shopping cart item just gets appended to our base URL here in the program.cs. And then we're sending over the item create object, right? Then we say if it is a success code, okay or no content or whatever it is, we know the different codes represent different things. So an okay response is a success code. Then we just call the await on initialized async, which basically just redraws the entire thing. So for the uninitialized async, we just say items, which is an array of shopping cart items, is equal to http dot get from JSON async shopping cart item in a form of array, and we have the same root there. All right. I'm not going to go all out with architecting and best practices in this particular example. I'm just showing you a quick win, right? If you want all of that, you can check out my Blazor courses. So our uninitialized async gets all the items and puts them inside of this object, which is designed for the items. Handle create basically just says post whatever data came over as JSON to this endpoint, and then go ahead and update once it was successful. Now, the rest of it would just be me changing out the weather forecast sample code that was there and just using items where it would have said forecast, and changing out the table headers according to my new table headers based on the new data. And then for each item in items, remember items coming from our API call, I'm just updating or displaying, the different values. Now for the checkbox section, I have an input which is of type checkbox. And I just gave it a class so it looks kind of nice. The value is going to be bound to whatever item.collected is. And on change, this is an event. That means that whenever you change the value of the checkbox, I want to call this method checkbox clicked, pass in the item and pass in the value of the event. So because it knows it's a checkbox, that event is going to have data. Was it true or false change, etc. Right? So we're passing in that value. So when that checkbox clicked method gets called, it is going to take that shopping cart item, and this could easily just be, and probably really should be, the update or the put, whatever object type we had used there. But of course, it's going to clash here because this is of type shopping cart items. So I'm just showing you that I'm taking the shopping cart item object here, and I'm taking the checked value as my event args value, right? But I have to make it an object at this point. Then I formulate my update shopping cart item object and set the value that I know needs to be set. And then I'm going to send over put as JSON async that object type, and I'm going to be calling the URL, and then using interpolation, I'm just sticking on item.id. So that's why it was important to pass over the item, because in doing the update, we may need data about the original item, like in this case, the ID. So I'm passing over that ID and the whole object with the data that represents the update. And then if it was successful, then you redraw, right? Then for the delete, we have a simple button. Give it some bootstrap class, and then on click, we have similar code, event, and pass over the item. So pass over all the details about the item to be deleted, even though we really only need that ID. So we are just going to say var response http.delete async, not as JSON because there is no JSON to be passed over. There is no data to parse. Just delete, and the URI would be API/shopping cart item or item.id, and then we redraw. So that is why you get that sort of real-time look and feel to the UI, because I keep on redrawing each time the operation was successful. All right, and that's really it for Blazor interacting with the API. Of course, it can get a bit more complicated based on your needs or whatever. Of course, the API could be a bit more complicated. But once again, we're just looking at quick wins. And once you understand these core concepts, you can always build on that for your future operations. So that's it. You can hit pause at the different points and replicate the code. I'll just scroll through slowly enough that you can hit pause at the different intervals and you can see all of the code. And I would encourage you build more endpoints or more behaviors in your API and build more pages and components to interact with said API. Once again, make sure that you update your base address and make sure that you enable the CORS settings on the API. To test them simultaneously, you'd want to go to the solution, right click, go to properties, and then you'd want to select multiple startup projects, and you can put both to start or both to start without debug, whichever one you prefer based on your testing process, right? So that's really it for testing using a UI. Welcome back, guys. In this lesson, we're going to be going through some of the changes needed to start talking to the database. So the database that I've selected for this exercise is an Azure Cosmos DB database. We already have some experience dealing with that. We looked at using it as an input trigger or input binding rather, and how we just pass the data in and it will communicate with the Cosmos DB. In this, we're going to be taking a slightly different approach to just using input bindings because there are certain operations that we want to do, and I think it's mixed. We can write the code 3 different types of ways if we use the input binding, because based on the situation the code is going to look differently, or we can be a bit more consistent. So I'm going more for consistency in this situation, and I'm going to show you guys how you can, one, set up your function app for dependency injection, and two, how we use a Cosmos DB client for that whole injection, which can be used all over the place anywhere else in any other function. So to get started, I want us to go over to NuGet. Just right click your functions project and go to manage NuGet packages and get this one, microsoft.azure.webjobs.extensions.cosmos.db. So this package actually gives you an API for Cosmos DB as well as table storage, but we'll be focusing on Cosmos DB right now. The next thing is to create a startup class. Now, a startup class would be similar to what you see in every .NET Core application. So we have a Blazor app here. In .NET 6, it looks a bit more condensed than what you're probably used to, but this is pretty much that startup class that they kind of condense into one file. So this basically bootstraps a number of services to be readily available for dependency injection anywhere in the application once the application is running or once you're writing code, right? So that's what that does. So we created our own. I'm calling it startup.cs, and I'm just going to show you the code and walk you through each line so that we have a full appreciation of what's happening. So just right click your function app, add a new class, call it startup.cs. You might get an error or some feedback that you're creating a function type that already exists. That's fine, but you can just erase all of that, or anything that doesn't match what I have on my screen, you just go ahead and correct it accordingly. So we have the first annotation, assembly, colon, and we're doing a functions startup, and it's going to be type of startup. All right. And you might have to include some missing references as you go along. So you just do that accordingly. Our namespace is our shopping cart list. We know that already. And then we have our our class startup, which is inheriting from functions startup. Then we have private static read only I configuration root. Configuration is equal to a new configuration builder. where we're setting the base path to be the environment current directory. That's the directory of the project. We are adding a JSON file, app settings.json true, but then of course we have the local settings.json, so we know how to access that later on. And then we're adding environment variables, and then we just build. Then of course it would give you an error saying you need to implement the abstract class, which is functions startup, and doing that would generate this method stub for you. So it's a public override void, configure, all of that is generated for you. But inside of that method, what we want to do is say builder dot services and add a singleton. So a singleton pretty much means that whatever you're adding here is going to be one instance is going to be accessible throughout your application. So one connection to our Cosmos DB, the same connection to the Cosmos DB, will be used each time we access this dependency pretty much, right? So if you want to know more about dependency injection and how that works, you can check out my other courses, but I'm just going to go through with this now. So var connection string is equal to, and then it looks in the configuration, right? So remember, configuration compiled all of these elements, including our settings file. So we already have that settings file. Even though the name is different, it will contextually know where to find what. So we're saying configuration get me the Cosmos DB connection, which is what we called it in our local settings file, right? So we looked at this already. I'm using the emulator, and I'll show you in a few the database that we've created. So just make sure you add that key, Cosmos DB connection, and then we add that emulator key accordingly. So we're calling that DB connection, and then we're saying if it is null or empty, then throw an exception. Otherwise, return a new instance of the Cosmos client builder with the connection string dot build. So that is our startup class that we have configured once again, so that we can inject whatever dependencies we've defined. We only defined one, which is for the Cosmos client. Now let me jump over to our Cosmos DB. We already have some experience with this. This is our emulator, so you can go ahead and go to your emulator and create this new one. So we have a new database. I'm calling it shopping cart items. And then my collection name is items. And for my key or my partition key, I'm using this word category. So we're going to be making some changes to the models as we have them. But remember that the partition key is like a high-speed lookup. So it kind of like indexes your records or your documents, quote unquote, so that it can be found faster. So we're adding a new property called category, which makes sense, right? It's a shopping cart item list. What is the category? Is it food? Is it clothing? Is it a need? Is it a want? Etc. Right? So with that, we can better partition the data and speed up the lookup, speed up the operations against this whole database. So you can go ahead and do that. So after you've created the database, let us look at the changes to be made to our models. So the only change I'm making is really to the shopping cart item, and I'm making a change to create. So let me go with the shopping cart item first. So shopping cart item, one, I'm making it inherit from table entity, which is courtesy of this new class, Microsoft.WindowsAzure.storage.table, which comes in our new package, right? And so you can let it inherit. You don't necessarily have to, but the benefit, quote unquote, of letting it inherit is that the class or the model will now actually have access to all of the properties that get attached whenever a document is stored. So you'll see a lot of other meta tags. You probably noticed them from when we did the blog exercise. There are a number of other meta tags that get attached. So once it inherits from table entity, it will actually be able to parse them over. Now, I've also added a JSON property annotation to our ID property. Sorry. So this JSON property basically says that, yes, I know I'm capital ID in C# world, but in JSON world, please make me a common ID. The relevance of this is Cosmos DB is looking for a property with common ID. So when we set that ID value, you'll actually get a bunch of errors. You can try it yourself. I actually had a little field day with it until I remembered that I needed to put this there, right? So you can actually try, after I show you all the code and everything, try to do a create and you'll see the errors that you get. It will complain that it's missing the ID column even though it is there. So we just say when you're in JSON, please identify as common ID, and then Cosmos DB will be able to see it and say, okay, I see the ID value present. Of course, we're not allowing Cosmos DB to generate the ID. We are doing that. So that remains the same. I've also added another property called category. So like I just said, category is going to be our partition key. And just like with the ID, we need to let it know that it is a common case category. Of course, this just needs to match how you wrote the partition key, right? So I'm just going to leave it like that. Capital C for code, but common C for JSON. Then inside of the create, I'm also putting in that category. So when you're creating the item, you say the name and the category. And of course, there are better ways, quote unquote, to do this. You could use enums, you could use a select list, etc. But for now, we're just going to keep it simple just so we can understand the exercise at hand. For the update, that is actually kind of optional. So actually, I'm going to take it out and I'll correct the code when we get there. So I'm going to remove that. So the update doesn't change, right? So we're just adding category here. And for the shopping cart item, we're adding that and this JSON property as well as the JSON property above the ID. All right, so we're coming along nicely. Let's jump over to our function. Now you'd notice one, I have removed all of the static keywords, right? So public, this was public static class. I've removed that because static classes can't have constructors, right? And we need the constructor for our injection. Another thing is that, sorry, I just removed that line. So if you started typing it, you can disregard it. I apologize. So another thing is that we can't have static methods because we have to modify the code in there. And that means we have to use the private fields that are going in, right? So as soon as I explain what's going on here, I'm just showing you the error that you'd get if you left the method as static. So no static class and no static methods. All right. So let us go through line by line and see what is happening here. So firstly, I'm injecting the Cosmos client. Cosmos client is coming over from our startup. So this is returning an instance or the dependency needed for us to access the Cosmos client. So I'm just going to write a constructor. Shortcut for constructor is CTOR tab, and then you could actually just write in the Cosmos client, and then using control dot, it will offer to initialize and inject the field for you. So I'm just showing you keyboard shortcuts so you can write it in quickly. So we want the private read-only Cosmos client, and that gets initialized inside of our constructor. And then we have a private container, document container, and then we're going to say document container is equal to Cosmos client dot get container by the name shopping cart items with the collection items. So if you hover over that, you see it asks for the database ID and the container ID. All right. So with those two, with the document container, I can now access the database, the items, and do all of the operations I need. So I was making the point that I find this a bit more consistent to do with a few lines than writing in individual triggers or binding code per method, right? So what would have happened is that I would have to write Cosmos DB, and then I have to initialize the Cosmos DB to have the connection string value. So I'm going to do that quickly and show you what it would look like. And that's it. So that's what our annotation would look like as an input binding. So when we looked at input bindings previously, we did it with a TypeScript project where we actually modified the function.json file. There's no function.json file that gets generated for us when we're using the C# project. So we actually put in the bindings and the triggers right here in our function. as annotation. So it would say Cosmos DB, what is the database name, what is the collection name, and then the connection string, which of course would just point to the name in the app settings. And then we would call it document client client. Now, based on the situation, you might end up using different data types here. So for getting all items, we would use the client, and then the query code would look like this. All right. So first we would have to find a URI or generate a URI for the collection. So I'll say URI factory dot create document collection URI, and then we give it those. So here you're seeing that I'm repeating these strings all over the place. You'd probably want to think about using like a constant class, a constant for the database name, a constant for the collection name, etc. Right? So notwithstanding that, we would just pass in the database ID and the collection, and then we would say iDocument query relative to the data type we're about to query, and then document client dot create document query, and then we pass in the URI as document query. Now these can be extended to have like where clauses, so you could even say like where, and then put in some condition by which you want to find the documents, right? So it could be that you want to find or do like a search. That would come in handy for something like a search. Either way, this would return all of the documents, and then we'd say while the query has more results, we would query through them and then potentially populate a list that we would intend to return. So like we had that list up top, I've removed that also, and I'm just using it here locally, right? So you would actually just add each item to the list if that was what you were doing. So we're not taking that approach. I'm just showing you because it's good to know your options, right? So that I'm going to comment that out, and I'm going to comment this out. So at least when you look at the source code later, you can see that this would have corresponded with that code. However, because I've injected the client up top, I can now go straight and say, so firstly I have my list generated here or declared, and then I say var items is equal to document container dot get item query iterator relative to the type shopping cart item. This is going to basically go off and just get everything, and then we'll say while items has more results, we will just go ahead and add the range to our new list. All right, so var response is equal to items.read next async, and then we just drop that range into, drop that list into our list, and then that's what we return. And come to think of it, I could probably even cut this line short. Let me see if this would work, and say items.read next async dot. Okay, so it's an asynchronous, so of course I would have to await. But then if I do that await, then I would be able to do a toList on what is returned. There we go. So I probably don't even need all of this anyway. 2 lines, right? So you see, sometimes you write something and then you realize I could have written it a bit better. So I'm going to comment that out for now, and then we can come back and test and validate if my refactor works as expected. But you see, go out, get the items, and then we get them is in items.read next async, which basically reads out what is in the items. We wrap that in a brace or in parentheses so that we can call the toList on whatever is returned. Right? And that is what we're returning when we try to get all. So let's move on now. So the get by ID. So here is where it would kind of be a like for like based on what we did previously, where we actually had that binding where we looked for the ID and for the partition key, which in this case is category. So here I've modified the root to say give me ID and partition key, and then those are the values I'm going to use to run my query. Right? So I could actually have used the same kind of binding that would have used previously inside of this method here, and that would actually help us to get back the one record that matches this ID and partition key. So here's an example of what that would look like, that binding code. So Cosmos DB, we have the same database name, collection name, and connection string. And then I'm going to tell it that the ID is bound to the ID coming in from the parameter here, and the partition key similarly is bound to the partition key coming in here. And then that is just going to basically go to Cosmos DB, do the lookup, and store the result inside of shopping cart item. And then once we have shopping cart item, it would be as easy as returning okay object result with the shopping cart item. But like I said, I prefer the kind of consistency, because this this binding code is going to look almost entirely different from this binding code, and you have to be very careful. And I'm not saying it's bad. I'm not by any means bashing the code. I'm saying that it's not my preference, right? But I am showing you what your options are. So I'm going to comment this out so that at least you have it as a point of reference. But what I have done here is to say var item is equal to await document container read item async. So get item query iterator. That's how we get our collection. This one is when you want one. We want a shopping cart item, and I give it the ID and I give it the partition key, which is category. Of course, I likewise extended the parameter listing to include the ID and the category. And I adjusted the root, like I pointed out, to have the ID / the category on it. So when you're trying to get, you should pass in the ID of what you're getting as well as the category name. So you can do a quick lookup, right? So that is what we do. And then the item is actually going to come back with a status code, right? So it's going to say if the status code is equivalent to HTTP status code .not found, then we return a not found result, right? Nice and simple. Otherwise, we go ahead and return the OK result or OK object result with item.resource. So you'll see that I wrapped it in a try catch because I was doing something wrong when I wrote this and I needed to see the exception. So you can do that if you need to, but it's really and truly not necessary. So I'm going to remove it just so I can simplify the code and show you exactly what is required. All right, so that's how you would look up one record from the Cosmos DB data store. Now let's review what happens when we do a create. All right, so what we're doing here really and truly is saying that we want to do the same kind of binding. So of course I commented it out, but if you look at it, it's the same kind of binding, except this one would be an outward binding, right? An output binding. So this is an input binding. This is an output binding, because then it's going to output something to the Cosmos DB. So essentially it is getting the Cosmos DB collection database. We know all of that, but then the last parameter here is of type IAsync collector relative to the data type we know we want to process, and then the name of it. So let me put it in the same line so it looks a bit more uniform, right? So that is the data type we have to use because we're operating asynchronously. If we weren't doing it asynchronously, then we would just do an out variable, but you can't use out variables inside of an asynchronous method. So we have to use the IAsync collector relative to the data type and then shopping cart item. And then later on in the code, after we get the shopping cart item and everything, we would actually have to do something like this to add it to the collection. So I would say await shopping cart items out. So I corrected this name. That should have been shopping cart items out. I'm just naming it that because we know it's an out. It's outputting to the Cosmos DB, right? So shopping cart items out dot add async, and then we pass in the item that it should be adding. That's really what would happen at the end of that operation, right? So the commented out code matches the commented out code, right? So what we are doing, however, is we're saying, of course, we know we get the data from the body, we parse it accordingly, and then we create a new item of type shopping cart where we pass in the name and the category that came in through our request. And then we say document container dot create item async. We give it the item and then we give it the partition key value. Now the relevance of this partition key value is that we are using the category that was sent over as the data, right? So when I set that category, or when you're creating this item and that category, we're creating it and we're setting that value. So when we did our blog example, we had used the ID for both ID and partition key. In this case, I'm showing a more practical example that you'd really want to slice it based on something like category or groupings, right? So we're using the category as the grouping. And then once you do that, we just return the OK object result with the item accordingly. So either one of those lines would work relative to the uncommented or the commented out code. So let us look at the update. And because I removed the category from the update shopping cart item, we're getting this error. But when we get there, we can look at it. Now, I'm not going to spend time looking at the alternatives for the put and the delete. You can go out and research those. I'm just going to press ahead and show you how I have done it. So I updated the root, or I need to update the root to include the category, right? So I did not put in the category, because the way we're doing it, we always need that partition key. So I need to extend this to take the category. Of course, the method is put. So we're getting the request data, parsing it over, and then I'm going to save our item. So I'm going to go and fetch the item from the database. So we're using the same code that we would have used in the get single, right? But this time the partition key is coming in from our parameter category, or well, just the same way. So I need to make sure I put string category. All right. And then once it finds the item or not, it's going to check. Okay. If it found it, then we move on to say item.resource. So the data, after it has fetched it, the actual data is stored in item.resource, right? So that is why we returned item.resource up top and not just the item. I don't know if I pointed that out earlier. So item.resource, and then we update whatever we know we need to update. We know we're only updating the collected. So if you extend it to have name and whatever, it would be item.resource that property. And then we await document container dot upsert item async, where we send back the item.resource pretty much. So after we update item.resource, we send it back, and then that is what we're going to return anyway as the updated data. In the delete, we once again update the root. So we're taking the category as our partition key. And then we're just going to say await document container delete item async. And we're saying we're deleting a shopping cart item. We want to delete the ID and that particular partition key. And then we return the OK result. So that's basically it for this operation. All right, guys, so let us test it out. Anytime we do something cool, we have to test it, right? So I'm going to just bring up Postman, and I already did a test with the post where I created apples and I gave it the category fruit. Here is the successful return. We can go and get, so this is getting all, and I have two records in there. I have the sandwich and I have apples. One is in the category food, one is in the category fruit. So earlier when I was testing, I was actually using needs and wants as my test. And what I noticed was that it actually returned a 500, right? So I have a correct ID and incorrect partition key. So that really should give me a 404. It means it cannot find what I'm looking for. A 500 indicates that there's a problem on my server, which is not accurate. So if you look over here, you see that it's actually throwing an exception because the HTTP client that is making the call to Cosmos DB has a method in there that says ensure, or a property that says ensure success code. So if it sees anything other than a 200 or one of those 200 response codes, it's actually going to throw an exception. So even though it is saying that it's a 404, it's throwing an exception, which is manifesting as a 500 to the client, which we don't want. So what I've done is to refactor it a bit. So I'm showing you the code that is being called and that is throwing an exception. My refactor would have me do a try catch and make that call inside of the try. Then I return the OK object result. And then for the catch, I'm going to say catch the Cosmos exception in the form of an object called E. So Cosmos exception is the custom exception that is being thrown by that method. And then when the status code is equivalent to, and we can just use the built-in status code enum for not found, then we want to return a new 404, right? So that is my little refactor. So I'm going to restart this and try that again. So if I execute this again, let me just make sure that this is running. So if I execute this again and press send, now there's no instance or there's no indication of an exception in the log, and we're getting a 404. So that's much better, right? So I wanted this as food. So let me try a cart request that should not give a 404 or a 500. And there we go. We can retrieve the record successfully. Now let's try a put. So initially I had the category in that. I'm going to take that out and I'm going to just leave it at collected is true. Let us update our ID value. So the ID and the partition keys needed for the put. Let me put both and then update. So now you see that this is true. So initially we know it was false, right? Now we can see that it is true. So the update works. And then let us delete. And once again, we need to put in our ID and the partition key for the delete. So let me just do that. And that's a 200 OK. So if I try to get again, then I only get one. So all of our CRUD is working with our Cosmos DB. Of course, if you want to further validate this, you can bring up the emulator, look in the emulator, make sure it's there, and then do all of your adjustments accordingly. Play around with it, explore, see what is possible. All right, guys, so we just went through quite a workout setting up our application to use Cosmos DB, right? So let us just quickly go through some of the UI changes that have to be made since we updated the roots information for some of our endpoints. Like we changed the get to also need the partition key, stuff like that. So of course the endpoints will need to be updated accordingly. So in our client app, we can leave the root API endpoint or the base address as is. But then in our component, I am going to make some adjustments to the update and the delete, right? So for the update, we had said that, yes, we take the ID, but we also want the category. So I already have access to the item. So I'm just going to say / add on the category value also. And the same for the delete. We're just going to add on the category. And that's really all there is to updating these endpoint calls. Of course, if you're extending it to, have like a details page where you click and see just the detail of one record, then you'll need to consider that. Let me just delete that dead piece of code and show you another update that I made. Initially, I had this as value equals, and it was bound to the bool, but that should be checked, right? So the input type checkbox checked is equal to whatever value that is. And then we have that event and nothing changes for anything else. So I'm just going to quickly test this out. All right, so that is our user interface. I'm going to test this again. Blazor test with Cosmos DB, and the category would be random. Create shopping cart item. There we go. All right. Of course, we could always update the code that it empties out the text boxes as long as something is added successfully. Now, before you would have noticed that, yes, it was calling, but the check value wasn't showing when it was true or not. So we just updated that. So if I check this one, let me just bring up the console window so you see that it is going to call the update. There it is. The put was called successfully. So if I navigate away from that page and come back, it's going to run a fresh query. And sometimes when you interfere with the console, it pauses. But there it is. That's a fresh query, and now the check value is showing. So if I delete, we can see that the function was called, but this is not redrawing, so I can probably revisit that. But if I navigate away and come back and allow it to run the get, then we see here that it actually was deleted. So we can probably update the UI code to redraw properly after a delete. So the quick and easy fix for that is to modify our on-click event callback method. So instead of doing the way that we did with the event args and then we call the method name here, we're actually just going to have our @ sign, open parentheses, then open and close. So it's more like a delegate function, and then we're delegating it to our delete clicked item, right? So pretty much that will just solve that redrawing issue, because the way that the component loads, the way we were doing it before, it would actually try to reload everything before it actually registered that the items list was updated, right? So, and another thing that you might see me do is use a list instead of an array. That really has no material effect. I just tend to prefer lists, but arrays might be more efficient. That's besides the point at this time. So that's how you can get that delete to redraw the page properly. But that's really it for the changes required to our client app. All right, guys, so let us get started with our deployment. So we are going to right click our function app and go to publish, and then we get this wizard. So we want to publish the Azure. We select that, and then we need to specify a target. Now, I may have inadvertently mentioned earlier in this course that if you're using Windows, then you may want to use C#, and then you can use other languages for other platforms. The reality, however, is that .NET is actually cross-platform. So C# will work as well on Windows as it will on Mac and Linux. That's the reality. So your function app at the basic level can be deployed on the Windows version of this function app or on the Linux version of this function app, just the same way that Python, Java, and TypeScript and JavaScript and any other language can also be supported. You also have options to publish them as containers with Azure Container Registry, which can allow you to host your Docker image. However, I'm going to proceed with Windows. So after selecting Windows, we can now view or search for function apps. So I already have a function app that we had created from the start, but I'm not going to use that. I want to create a brand new one. So I'm going to click create a new function app, and then it's going to ask me for the name. So I'm going to say shopping cart API, the subscription name. Of course, at this point, you may be prompted to sign in with your Azure account, so you can proceed to do that. I'm going to leave it in one of the existing resource groups. There we go, function app RG. If you don't have any resource group, you can actually just click new and then create a new name. And then we have our plan types. So remember that we have the consumption plan, the premium plan, and the app service plan. So just to recap what the plan types are and the different pros and cons of each. The consumption plan is the serverless plan. It's the most affordable plan. That's 2 pros. And a con is that it actually has limitations with the execution time. So after about 5 minutes or so, the whole app will actually wind down. So it will kind of deallocate the resources. And then when you make another request, it will take time to spool up again. So of course, for testing and for quick wins, that would be a good approach. However, for a real scenario in a production setting where you need maximum efficiency and maximum uptime, you would probably want to use premium, where it does not wind down the resources. You have dedicated resources at all times, and you can access VNets and other resources on a network at a network level. Of course, this costs a bit more. Your other option would be if you use an app service plan. So maybe you have like an app service running a website already or another API. You could actually just deploy it onto that plan also. So I'm going to go with the consumption plan. So after you select that, you choose your location, of course. And for me, that would be East US 2. And then you choose your storage account. I only have one, so that can remain. And then we go ahead and click create. And after that is completed, we're led back to this dialog box where we can choose to run from package file. So that is ticked and it is recommended. Pretty much what it's saying is that it will actually deploy more like a zip file with all of the required files, the DLLs and resource files that we need. And it will mount like an image of the app instead of the actual files being there. So without trying to understand the intricacies of it, I'm just going to leave it ticked as it is stated that it is recommended. So I'll follow their recommendation. Then we can hit next. And then here they want us to decide, do you want to publish like a regular website? So before there was CI/CD, this is how we used to publish. You would generate a publish file, deploy all of the files to a particular place, whether on the network or your machine, and then you can copy and paste them to the destination. Or do you want to use CI/CD with GitHub? So I've already added this to GitHub. If you want, you can always go ahead and do that. You can add to source control using this option that would have been in the bottom right hand corner of Visual Studio. After you do that and you upload it to GitHub, then you can probably come back here. All right, so I'm going to use CI/CD with GitHub Actions and then finish. So that means each time I check in a change, it will actually trigger a deployment. Now we're led to our final screen where they're just giving us a summary of everything that has taken place. So it's actually going to add this new file, which is called a YAML file or a YML file, which basically has all the deployment instructions that GitHub is going to use to determine what needs to happen. We also get a preview of the URL that will be generated for our Azure app. So everything that we need, we can access it live through that URL. That's where our API will be accessible. And down here, we'll see some of the dependencies. So application insights needs to be configured. Let's go ahead and do that. Remember that we would want to have that for the logging. So you can actually just go ahead and click next through this wizard and allow it to finish. And once you've done that, it will show you a green tick that's configured. They're also showing you that they will replace the Azure storage settings for us, right? So locally, we're using the emulator, but once we deploy, we'll know that it should be using the real storage account. All right. So with all of that done, and if you wanted to modify the YAML file for whatever reason, you can go to more actions, click edit, and it's showing you what is required, right? So like I said, this will actually be triggered when we do a check-in. So if I open the Git changes window, you see that it's adding all of these changes. And then I'm going to say deployment activity or deployment commit. And then I'm going to just commit all and sync, save all changes, and allow it to push to the repository. So we can jump over to the repository in GitHub and we can just click that little dot that appears beside the check-in or the commit number. So if I do that and click details, we'll jump over to that CI/CD screen. So let's give it a few to finish up. And after a few minutes, it should be done. All right. So let us jump over to our dashboard and let us look at our resources. So I'm going to go to all resources and I should see my new function app. There we go. Now, before we go any further with the function app, remember that we do need a Cosmos DB or whatever kind of database you would have used. You do need that to exist in order to have that connection ready for testing. So I'm going to jump over to our dashboard and I already created the Cosmos DB, but I'm going to walk you through the process regardless. So, you can go to all services and then you just go and search for Cosmos DB. Once you have the Cosmos DB, you would create. And then we're using the core SQL. Now on this screen, you choose the resource group. So I recommend that you choose the same resource group as your function app, of course. You enter an account name. Now the naming is very strict, so you can't use any capital letters or anything. So I would have called it shopping cart items. Of course, that's really just an account name, so you don't necessarily have to call it that. But you give it that name. If it tells you it's not available, you just try and make it a little more personalized, right? And then you choose a location that's best for you. Once again, I recommend choosing a location that is as close as possible to where the function app was deployed. So once you do that, you can choose whether you want the provision, throughput, or serverless. And if you choose serverless, obviously you don't have the options below. But if you choose provision throughputs, then you can choose to apply that free tier discount. Now, what I have experienced in the past is that I wasn't able to proceed with the free tier discount on the second and third try. So I'm just pointing that out. If you try it with it applied and you end up having a failed deployment, you'd have to delete that resource, come here, try again, and I recommend that you click do not apply. Of course, if it's your first time, then you can leave it on that. But if you choose do not apply, then it will start costing you, or you can just choose serverless. You also can change the backup policy to save costs. So since this is not a production system, you don't necessarily have to go geo-redundant. You can do locally redundant backup storage, so it costs less money. But if it's production, then I recommend that you leave that on geo-redundant. So those are the two real settings that you would have to make sure are there. And what I'll do is jump over to my already provisioned Cosmos DB account. Once you're here, you want to go to the Data Explorer. Now, this Data Explorer looks just like what we would have experienced with the emulator. So you create your new database according to how you would have written the code, of course. And pretty much whatever you did in the emulator, you just repeat those steps to create your database and the container, as well as the partition key inside of this one. All right. So with all of that set up, we want to make sure that we get the correct connection string. So here's that primary connection string. We can copy that and then go back to our function app. So I'm just going to go over to the dashboard, jump over to the function app, and then inside of the configuration, we need to add that primary connection key. So remember, in our code, we would have set up that we need to look in the app settings.json. So locally, that would have been the local.settings.json file. That's what it recognizes as the app settings. However, in a deployed setting, we have to set up our application settings. So you just say new application setting, give it the appropriate name relative to what we wrote in the code, which was Cosmos DB connection, and then you paste that primary connection key here. So I already did that. Here it is. I added that manually, Cosmos DB connection and the value. So once you have all of that set up, then you can proceed to test. So to test, we can click on functions, and that will give us the list of all the functions that have been deployed in this app. If I click any one of them, let's start with the get shopping cart items. Here you'll see like a little dashboard of all the executions. We've kind of seen how this dashboard looks already. If you go to code and test, note that you cannot write code for the function here because it was actually deployed from Visual Studio. So any edits have to happen in Visual Studio. It's really just mounting it, and it has the bare minimum as far as the configurations are concerned. So here it's showing you that the script is really loading from that DLL. That's the compiled version of the whole source code, right? So that is what we would see there. But if we were to go back and get the function URL, then we would be able to get that URL, which we can just paste in the browser to test. So if you want to monitor, as we saw before, you can just go to monitor and go to logs. And when that is connected and up and running, you can proceed to test. So I'm just going to open in a new browser, a tab, sorry, and paste. So here I'm getting that empty array bracket. But then if I look in the log, I would see that it called the function and there was nothing to share, right? So that means using Postman or any other API tool, I can actually simulate the same kind of calls that I'm used to. So here is where we would have created a shopping cart item. Instead of posting to the local host, I'm going to replace all of that with our new URL to our Azure websites, send the request, and there I have it. It's a 200 OK response. So that means if I refresh this request to get all, now I'm seeing the object in the database. So that's it really for publishing our function app to Microsoft Azure. All right, guys, so in this lesson, we're going to be bringing our client app up to speed. So what I've done is I jumped over to Visual Studio. I have up the program CS file, and I'm going to change this path from the localhost functions path to our deployed functions path. So from the dashboard, I'm just going to grab this URL, as that is our new base URL, and I'm going to replace this line of code. So I'll just duplicate the original and comment that out and paste this new address. So with that pasted, let's test it out. So I'm just going to right click this project and go to debug and start without debugging. And when we navigate to our fetch data page, you can see here I'm getting an error. So if I go and inspect and look in the console to see why, you're seeing that it failed to fetch. That's all it's really saying. But if you look above that, you see that it says access to fetch at that address from this origin has been blocked due to a CORS policy. So we had mentioned CORS policies earlier. CORS is the Cross Origin Resource Security Protocol. In other words, two things have to be on the same network or domain or framework infrastructure for access to be granted. So what I need to do is jump back over to the Functions app, go down to the CORS policy. There we go. And then add the URL. And once that is added, I'll save. And then I'll come back and try again and notice there's no error. And now I have data coming from Azure. All right. All right. So now that I've verified that this is working, let's jump back over to the program.cs. And what I want to do is configure this that if we're in production, we use the production link. If we're in dev, we use the dev link. All right. So that I can just set it up one time. So I'm going to say, give me var base address. I'm going to create a variable called it base address and set it to be this new URI. Or rather, let me set it to be this string, which is our local. And then I'm going to say if our builder dot host environment dot is, well, this is the development address. So I'm going to say is production. All right. So this is a nice, easy way to check if you're in production when you're using a Blazor WebAssembly app. And then I'm just going to say the base address is equal to this string, which is our published address. So then I can have one line where I say builder.services HTTP client base address is new URI of the base address value. So with that done, it will be dynamic. There might be more elegant ways to do that, but for now, this will work. So let us publish our app. So I'm just going to right click, go down to publish, publish, there we go. And then I'm going to create a new profile. So the profile that's there is already for the function app, but this time I'm creating a new profile. I'll choose Azure and I'm going to publish it to another app service. And it's going to ask which app service instances here that I have a few already. I'm not going to use any of those, or I probably can. That's fine. I'm just going to do a new one. So I'm going to create a new one. This would be the app service plan, right? So the app service plan is pretty much the base, and then you deploy to that base the app service itself. So I'm going to create a new hosting plan. I'm going to call it shopping cart list and put it in the same resource group as our function app. So the importance of assigning stuff to the same function, to the same resource group would be that if you no longer wanted the app and the resources for this app, you can just delete the resource group and everything in it. And that's a nice, easy way to clean up. So I'm just going to put it in there also. And I'm going to place this on a free plan. So by clicking new, I choose my location and then I can go down to the free plan. But of course, based on your context, you don't want to choose the plan that best suits your needs. So I'm going to go with free for this demo. I'm going to click create. And when that is done, I can just go ahead and hit next. And I will publish this with the same CI/CD setup as the function app. So I just click finish. All right. And then this summary page is letting me know what the pending URL for my app is going to be. So at that point, I can just go to Git changes and say setup deployment for Blazor, commit all and sync. And then if you want, you can jump over to GitHub and watch that deployment. And it's done. So let's jump over to the published site. Remember, you can just get that URL from the published profile or go to your portal dashboard and get it from the newly deployed app. And let's go to fetch data just to make sure it can communicate. and it cannot. Can you guess and tell me why? Well, if you guessed that the course policy is not set up, then you guessed correctly, right? So here we can see it's still complaining about course. Why is it complaining about course? Because that's a brand new domain name separate from the one that we had used initially, right? So I have to go back over to the function app, jump over to the course policy configuration, and add this new URL. And let me just make sure I meet the format. Save, try again, and enjoy the fruits of our labor. So that is us publishing our client-side app, which is communicating with our function app. Now, there are other things that we can do with this, other configurations that we can make along the way to make this a bit more seamless. I will discuss them later on, but for now, we have successfully published both the API and our client app.